Hey students, it is Tuesday, the 16th of February. We're looking at how does the pattern grow? It's our first day of chapter 5. So we're going to do some exploring and kind of trying to realize that all things don't grow by a linear pattern. So how else might they grow? And so start out today by going into your Desmos, looking at the do first, and the problem says this: would you rather get $10 or get 1 penny today and every day after get double the amount of pennies you got the day before? And it's a very open-ended question, and I want you to think through why you would choose one way or the other. If you're thinking, oh, there's an obvious choice here, think about it as a riddle, right? And so what would you need to know in order to make a better decision? And how much do you like pennies? So think through it for a little bit, right? Either $10 in your hand or a penny. The obvious choice feels like it's take the $10. But what happens when we double things? So let's think through this. What happens as we double those pennies every day? In 5 days, how many pennies would I be giving you? In 10 days, how many pennies would I be giving you? So think through that, all right? And then move over to slide 2 and look at this table. All right, so hopefully you paused. Took a moment to walk through how much money this would be, all right? So look through this chart and see what you see. All right, so let's take a little snippet of this chart and see what that really means to you. I'm not sure why that's not working. Give me a second. All right, so if you decided to take the $10, let me make your brain slow down for just a little bit, okay? After the first day, when you get 1 penny, the next day you'll get 2 pennies. So if I add these together, you now have a total of 3 cents, okay? The next day you get 4 pennies because that's double, so you have a total of 7 cents. Keep adding these up and see how your money changes. So after 4 days, now you have 31 cents. Add that to 32 cents from the next day, and you have 63 cents. Keep going, and you see how your money grows. So after 6 days, you now have $1.27. The 7th day, we add $1.28 to your total, and you have $2.55. The next day, we add $2.56, so now you have a total of $5.11. We're going to add $5. After 9 days, you now have $10.23. So 9 days, you have exactly the same amount of money as I gave you on the first day, and it keeps going, right? Add another $10.24, and you now have $20.47 after 10 days of that money doubling that you're getting handed each day. That grows pretty quickly, doesn't it? And notice it's not growing by the same amount each time, right? This is going up by 1 cent, then by 2 cents, then by 4 cents. It's going up by 8 cents, right? So you can see that it's growing differently each time. This is different from all the linear equations we looked at now. So let's explore what this means. And this chapter is really going to be about how do we attach a function, an equation to this type of growth? How do we see it on a graph? All right, so join me as we start looking through this. Make your way through the slides in the Desmos. Again, just watching this video isn't going to be helpful enough unless you're actively participating. So walk through our slides. You can see that we have some announcements for those of you who want to see those. If you're a female identifying student who wants to code, check that out. Look at our weekly overview. So today is our growth, day 1. Tomorrow we're going to take this to an even bigger extreme. Then Thursday we're going to review last week's assessment. So make sure you're here the rest of this week. All right, our goal today is to determine the pattern for exponential situations. So let's move on to an exponential situation after you set your own goal. So pause it right here on slide 12. Make your goal. Take a look. These are all the new topics we're going to be learning in chapter 5, so patterns and sequences. So go ahead and walk through here. If there's any words you don't understand, go ahead and underline those. I want you to look at this word here. It's arithmetic, say that out loud, geometric, all right, linear, exponential, recognize a situation as exponential, create linear equations from arithmetic sequences. We know what linear means, so what's arithmetic mean, do you think? Create exponential equations from a geometric sequence. Create exponential equations from graphs, tables, and situations. So again, we're going to be creating all these different functions and new equations. Compare exponential and linear situations. Create recursive equations. What's that recursive mean? What's the definition of a function? That's a little bit of a review. Domain and range. I know you learned some of these in middle school, but we're going to revisit domain and range. And then what does it mean, rate of change? We learned rate of change when we started looking at tiles. So what's it mean now with exponents and exponential functions? All right, we are going to investigate this problem by talking about bunnies, by bunny rabbits. You maybe have been able to read the book of Mice and Men by John Steinbeck. And in that book, there's two characters, Lenny and George. They're going to raise rabbits, right? That's their dream. And so let's think about this. If they have 2 rabbits in month 0, right? They start with 2 rabbits. And those 2 rabbits produce 2 more rabbits. How many rabbits would they have in month 1? Well, this seems pretty easy, right? If they have 2 rabbits, and those 2 rabbits create 2 more, we now have how many rabbits? And my rabbit drawing is terrible. You might want to do this in your notebooks. So 2 rabbits create 2 more, and so after month 1 we have 4 rabbits. Well, now how many rabbits are we going to have in month 12? And I know a lot of you are thinking, oh, it goes up by 2 each month, so I'm going to create 6, 8, 10, etc. And that is not correct. Okay, that would be a linear growth, right? If these 2 rabbits had 2 rabbits every month. But guess what's going to happen to these 2 rabbits that they had? These 2 rabbits are going to create 2 rabbits of their own. And this could get really dirty if I did it a different way, but we're saying create, right? So after the second month, these 2 rabbits have another set of 2. The 2 new rabbits have a set of 2. So how many rabbits is that? Count it up. 1, 2, 3, 4, 5, 6, 7, 8. And so after month 2, that number of rabbits grows to 8. Well, now we have 4 pairs of rabbits. And the problem says every month the rabbits grow, or every set of 2 rabbits has 2 more rabbits. So look at this. We have this set of 2. They're going to have 2 more rabbits in month 3. This new set of rabbits, they're going to have their own set of rabbits in month 3. This new set of rabbits, guess what? Another set of rabbits, month 3. And this set of rabbits that they had in the first month is going to have their second new set of rabbits in month 3. So all those purple rabbits are the new ones in month 3. And if you count those up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 rabbits in month 3. Wait a second, I see some growth happening here, but it's not the same as I was looking at in our last lessons, right? 2 goes to 4, 4 goes to 8, 8 goes to 16. Any guesses how many there'll be in month 4? Well, I'm kind of running out of room, but let's sneak these in there. Let's go with the red color. So this set of rabbits, right, is going to have 2 more. This set of rabbits is going to have 2 more. This set of rabbits has 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 2 more. This set of rabbits, right, this is a new one, has 2 more. And let's see, and our original set of rabbits is going to have 2 more. Oh man, that's a lot to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Did you guess 32? I think you might have, because do you see that all we're doing in this table is we're multiplying the previous output by 2. So we had 2 times 2 here. This next one we have 4 times 2 to get 8, 8 times 2 to get 16, 32 times 2 to get our next one. So our next time we're going to say 32 32 times 2 is 64 rabbits that next month. Then we're going to do 64 times 2 and get 128. So go ahead and fill out the rest of the chart. Oh, that's not what I wanted. Let's see, 32 times 2 is 64. 64 times 2, 128. 128 times 2. And if you're typing this in, that little multiplication symbol is just the star above 8. So hit Shift 8 to get that. So go ahead and fill that out and come back and see if your answers match. So go ahead and take a look through this. Do you have the same answers? How many rabbits would there be after 12 months? Well, if you have 8,192, you did it correctly. So how would you describe this change each month? Okay, how would you describe the growth rate of the rabbits? Would you say something like this? We multiply by 2? Well, that's the right idea, but I want you to think about it this way. We take the previous month, we're going to call that the previous output, and multiply it by 2. That might not seem like a big difference, but I want you to talk about this current month depended on last month, right? And so it means it keeps growing based on what happened the month before. All right, and so go ahead and go down to this chart. We're going to graph these first 6 numbers right here. So I'm going to zoom in just a little bit and be ready to graph these numbers with me down here. So 0, we started with 2 rabbits. And so that's barely above that vertical line or horizontal line. 1 month we had 4, so it grows a little bit. After 2 months we had 8. It's still going to be under that first line, which represents 10. 3 months we have 16, so I'm going to go 10 and halfway up to get right here. Month 4 we had 32, so I'm going to go 10, 20, 32. And then 64 is going to be above the 50, 50, 60, and almost halfway. Now I'm going to put one more in there. I'm going to say, let's go month 6, because month 6 we had 124. So I'm going to call this month 6 and go up to 124. So let's see. Up, that's 124, right about there. Now, is this a linear pattern? Well, let's connect these points, and I would connect them with, I'm going to just use these little lines, because what happens is you start to see this interesting curve. Oop, let me redo that one. And it's not a straight line. In fact, it's going to be this nice, easygoing curve until all of a sudden, boom, it turns and it starts going up very, very quickly. And I want you to think about this. It's not a linear growth, right? A linear growth would be this nice straight line from here to here, but that doesn't match our data. And so we're going to learn this chapter, how do we match our data with what we're doing? All right. And so what you need to do here, after you have all this down, rewatch it if it doesn't make sense. Tell us, what patterns do you see in the table and how could it grow? And then go ahead and join me in your Delta Math, and we're going to preview some of those problems today. So here we are in the Delta Math that was assigned on Tuesday. It's called Graphs, Patterns, and Linear Situations. This is the first one that is graphing a set of points. And so look here, they already did the tables for you. All you have to do is pick out 2 points that would fit on these coordinates and graph them. So I'm going to look right here. I see -4, 3. So that is -4 in the x direction, 3 in the y direction, and click on that point. Let's pick one more. 0, -9. That's the y-intercept. I like that one. So I'm going to go 0 in the x direction, 9 in the y direction. Click there. Now you can graph as many of these points as you want, but you only need to do 2. Click Done Plotting Points, and it'll give you this ruler. You just need to trace along the ruler all the way down, click Submit Answer, and you have now completed the problem. There's a whole bunch of these. Again, keep practicing until you have it down. If decimals show up, remember, do the ones that aren't fractions or decimals, because they will show up on your points. All right. In the next section, you're supposed to create patterns. So see how this grows by 2. You fill it in by saying the next answer is 13.